Good day. So in this topic, we will be discussing about basic terminologies as an introduction to our course Biostatistics. So by definition, statistics is the science of collecting, analyzing, presenting, and interpreting data, as well as making decisions based on the data, the interpretation of the data we have. So, statistics can be divided into two. We have descriptive statistics, which consist of methods for organizing, displaying, and describing data by the use of tables, graphs, and summary measures. So, in descriptive statistics, for example, here, it's a case study of the deaths due to red light running. So, descriptive statistics shows us that in 2009, there are 715 deaths. In 2011, it's 754. 2013, 739. In 2015, it's 831. And 2017 is 939. However, descriptive statistics doesn't tell us, it cannot tell us that there are significantly greater deaths in 2017 than there are in 2015. It does not. It just shows us the data as it is. We can say that there are greater number, by sheer numbers alone, there's greater number of deaths in 2017 than 2015 because there are 939 is a higher number than 831. But it's not significantly higher. So the key thing here is in descriptive statistics, it doesn't show it if the number, the difference between 939 and 831 is significant enough that you can say that 2017 is a very dangerous year for running the red light. It's just compared to, rather, it's significantly more dangerous than 2015. So, again, the keyword is significance. So, in descriptive statistics, we cannot say that it's a significantly higher amount. We can just say that the gross number is higher in 2017 than in 2015. So that's descriptive statistics. Now, in inferential statistics, this is what the thing that descriptive statistics cannot do. Inferential statistics consist of methods that use sample results to help make decisions or predictions about a population. For example, going back to this data, for example, as you can see, 2009 to 2015, 2017, there's an upward trend. So we can, in inferential statistics, we can say, or we can determine if there really is an upward trend. So the data here is just made using descriptive statistics. We cannot say that it's an actual trend, or we cannot predict, for example, 2019. For 2019, would it be higher or would it be lower? So descriptive statistics cannot do that. Inferential statistics, however, can be used to make the decisions or prediction. That is when we do inferential statistics, that is when we can say that A is significantly higher than B. So you can use the term now, significant difference, in inferential statistics. So other terms, so we have the element or the member of a sample or population is the specific subject or the object. So it can be a person, a firm, an item, a state, or a country about which the information is collected. And then we also have a variable. The variable is a characteristics under study that assumes different values for different elements. So for example, here, in our previous example of the years and the deaths, so we have the elements. The element here is the year, and the variable here is the number of deaths. So the number of deaths due to red light running. So basically jaywalking people. Here, you can see here that the element is the year and the variable is the number of deaths. So every year, the number of deaths is different. So that's your variable. Okay, so in contrast to your variable, so the value of a constant, of course, is fixed if it's a constant. Okay, so other terms, the value of a variable or an element is called the observation or the measurement. So for example, the observation is 939 for 2017. So that's the number of deaths. That's the observation for the variable number of deaths. So the data set is the collection of observation on one or more variables. So the data that we have, for instance, is the data sets. So each number. Okay, so here's another example. So the variable here is the annual cost. Each element is the university. and the observation is specific cost. For example, the annual cost is a variable because it changes for every university. So Stanford University is one member of the population or the sample that from which you are getting your data, and the value of the variable for Stanford University is 69,109. So that's an observation or measurement. So we have several types of variables. We have quantitative variables, under which it can be both discrete variables or continuous, or we can have qualitative or categorical variables. So for the quantitative variables, we have these are variables that can be measured numerically. So data collected on a quantitative variable is called a quantitative data. So for discrete, under quantitative variables, remember we have discrete and continuous. So if the value is countable, it's called a discrete variables. So that means for a discrete variable, there is no intermediate values. Basically, some people can simplify it as whole number values, but it doesn't really have to be a whole number of values. For example, your grade in Mapua are discrete values. They are considered for the course grade. That's the discrete variables, because we have 1.00, 1.25, 1.5, 1.75. What else? 2.0, 2.25, 2.5, 2.75, and 3, then 5. So those are countable variables, and they are also discrete. So there is no 1.76, there is no 1.85. We just have 1.5 followed by 1.75. So there's no intermediate values for that. So they are not whole numbers, but they are also discrete variables because they are countable, and there is no accepted intermediate values between the variables that we have. So that's your discrete variables. In contrast to that, we have the continuous variable. So it's a variable that can assume any numerical value over a certain interval. So for example, your weighted average in your grade. So for example, your weighted average could be 86.5, 86.55. It can also be 59.999998. So that's your weighted average. Those can be continuous variables. So for the qualitative or categorical variables, so they are a variable that cannot assume a numerical value but can be classified into two or more non-numeric categories. And these are the qualitative or categorical variables. So data collected on such variables are of course called qualitative data. So just a simple diagram of the different types of variables. So for the variables that we have, for a qualitative variable, example here is the make of a computer, the model type, for instance, opinions of people, good, bad, not so bad, then the gender, male or female, and something in between. Anyway, for the quantitative variable, it can be discrete or continuous. So we have discrete variables as number of houses, cars, or even accidents. So we do not have 0.5 of an accident. So it's either 1 or 2. And then we have for continuous, it can be 1.66, 1.75, 1.76, 1.9998, something like that. Okay, so other types of data. So we have two basic types of data, the cross-section data and the time series data. For a cross-section data, these are data collected on different elements at the same point in time or a certain period of time. It's called cross-section because if you consider, let's imagine your number line as a sausage. If you cut the sausage, your number line, at a certain part, so that's basically a cross-sectional cut, and that is basically a data at a certain point in that number line. So you have a cross-sectional data. So here is an example of a cross-sectional data. So this is an annual cost for the attending universities in the US. So this is in September 2018. So at 2018, this is the annual cost. So it's a snapshot in time because it captures what the data looks like, or the environment, what it looks like for the cost of American universities on 2018. And for time series data, they are the data that is collected on the same variable for over a period of time. So here, unlike the cross-sectional data where you have several variables or several elements, uh, but only a single point in time, in the time series data, we are just looking on one element but over different time periods. So here is a population of the United States in over the years. So this is 2015 to 2019. So this is your time series data. So basically your years are moving. So through the years, but only on one member of the population, one member, which is the US. There is no United Kingdom, there's no Philippines there. Okay, so let's look at population versus sample. So a population consists of all the elements, so whose characteristics are being studied. So the population that's being studied is called the target population. So again, population is all elements, whereas the portion of those populations selected for study is the sample. So here is a diagram showing you what the difference between the population and sample. So the population is the holistic, basically it's a set of all the members under study, or all the members that you want to study. But the sample is just a few members of the population on which you can gather data. So a survey that includes every member of the population is your census. And the technique of collecting information from a portion of the population is the sample survey. So if if the data that you are gathering comes from the population as a whole, so that means every single member of the population will be data will be collected on every single member of the population. That's the census. And if you're only going to get a data from selected populations, that's your survey. So let's give you an example on that. So for example, during an election, the survey, especially right now because it's almost election time, we have been doing surveys, which candidate would be most likely to win the election. So those are survey because you are not everyone is asked. Only certain members, a certain portion of the population is asked on who will they vote for in 2022. Whereas when the actual voting comes, where everyone is, of course, ideally everyone should be voting, so every member of the population the vote of every member of the population is counted, that is considered your census. So that's the difference between the sample survey and your census. So a sample that represents the characteristics of the population as closely as possible is the representative sample. And in doing research, it's actually the goal. You want to have a representative sample in your study. That is why a sampling is basically an art form. It must be well thought out how you sample the population. So here are some sampling. How do you get samples from your populations so that it will become a representative sample? So we have here a random sample, which is a sample drawn in such a way that each member of the population has some chance of being selected. So in a non-random sample, some members of the population may not have any chance of being selected in the sample. So for example here, you want to have a survey, for instance, of say among students in Mapua who is using smartphones more often than laptops. So in a random sample, you are supposed to each and every student enrolled in Mapua must have at least equal chance of being selected. Whereas if you do a non-random because you got lazy and you just ask your friends who are Mapuan students, and that's basically your sample, those are non-random sample because it's based on your convenience of asking whether they wanted using smartphones mostly compared to laptops, for instance. That means the people that you don't know have basically no chance of being included in your study, in the sample that you have asked. So that's the non-random sample. So we have errors, of course, in sampling. Okay, so in sampling errors, you have here, sampling error is the difference between the results obtained from a sample survey and the result that would have been obtained if the whole population had been included in the survey. And any errors that occur in collection, recording, and tabulation of data are the non-sampling errors or biases. So here are the types of error. So you have the sampling or chance error. Well, basically, it's very, of course, in an ideal world, you always have a representative sample, but more often than not, it's not. You have a slight error in your sampling. And then for non-sampling or systematic errors, they are actually biases. Now, between the two of them, the systematic errors or the biases are the ones that we can correct. So selection, it can be selection error or bias, non-response error, response error or bias, and voluntary response error. What are those selection errors? So the list of members of a target population that is used to select a sample is your sampling frame. And the error that occurs because the sampling frame is not representative of the population is the selection error or biases. So basically, you have your, for instance, you again, on the terms of smartphone versus laptops. So your sampling frame, for example, are just the CBMS students. So you have an error there because you are just including members from CBMS and not from other schools. So that's basically a selection error or the selection bias. So error that occurs because many of the people included in the sample do not respond to the survey is of course the non-response error or biases. So that actually results to sample sizes that are small because they do not respond to the survey. So of course they are not included. So that leaves a smaller sample size. So response error or biases occurs when people included in the survey do not provide their correct answers. Whereas voluntary response error or biases occurs when a survey is not conducted on a randomly selected sample but on a questionnaire published in, well, basically it's based on voluntary response of the population or of your sample frame. So here is an example. Here is, for example, what is your output, or usually we find them in evaluation or service evaluation, for instance. People who avail of services like when you buy, actually in Lazada, it's more of a requirement to actually review your purchases. But if you do not really review your purchases, let's say for example, the application download of apps in Google's Play Store, for instance. Not everyone rates. I myself do not usually rate my responses in Google Play Stores. Even if I do like the game, I rarely do the response, or I really do rate the application. However, when I feel, or when people are not happy with the product, they tend to always give a very low score if they are not it's not what they are looking for instance, even though it's a good product but it's not exactly what they're looking for, or they have a trouble understanding the mechanics of that product, they give a low response. And because the people tend to respond more if they are unhappy versus the people that they do not respond even though they are happy with the product, the rating of a certain application can be lower than what it's supposed to be. Even though it's a very good application, it becomes low because most of the people that tend to rate it have a very low response, even though the greater majority, although silent, have a high rating on that certain application. So basically, that's a voluntary response error or bias. So some sampling techniques to avoid biases. So we have random sampling technique. So in random sampling or simple random sampling, each sample of the same size has the same probability of being selected. So that's a simple random sample. Whereas you have a systematic random sampling. Basically, for example, I'm just, let's say in a classroom, I'm just going to get 5 representative students from a class of 40 people. So if I do a simple random sample, I just do a simple lottery to get the members of my sample. Whereas if I do a systematic random sampling, I will arrange everyone alphabetical order or based on their sitting position, let them count 1 to 5, and I will get every 5th, 10th, 15th, what else? Multiples of 5. So 5th, 10th, 15th, 20th, 25th. How many students was that? 40. 25th, 30th, 35th, 40, 45th, and the 50th students in my list. Or for example, based on your count. So that's your systematic random sampling. So for a stratified random sample, you first divide your populations into strata, and one sample is selected from each strata. So the collection of all samples from all strata gives your stratified random sample. So for here, for instance, I will get let's say for example, in getting samples in say districts in Manila. So we will be dividing the city of Manila into its respective districts, and you will get one sample or one member from each district. So that's stratified random sample. And then for cluster sample, you will first, it's different from stratified in such that you first divide them into groups called cluster, and each cluster is representative of that population. And then a random sample of clusters is selected. And finally, the random sample of elements from each of the selected clusters is further selected. So for example, here, you want to get this is usually done in surveys. So you want to get, you first, for example, for the whole Philippines, of course, you have your regions. So that's your cluster. So each cluster will have a representative, or each cluster is a representative of your population, and then a random sample of your clusters is selected. So for example, if you divide per region, and you just get region 1, region 5, region NCR, region 7, region 8 as your representative clusters, and then you get random sample of elements each from the region. Or let's make it a bit slightly different, going back to the Manila sample. So of course you have Manila, you divide them first into its respective districts, and then, or say barangay, and then you just choose barangay Intramuros, Pandacan, Tondo. So those are representatives of Manila, and you get a random sample of elements from Intramuros, from Tondo, and from Pandacan, for instance. So the other districts, the other barangays were not part because you just get it from the cluster. So basically, that's cluster sampling. So in stratified, the difference is that in stratified, you each, for example, the district of Manila, you divide it to the barangay. Each barangay will have one representative of each. Whereas in cluster sampling, each cluster are the barangays, and then you just choose random representative of the clusters. Intramuros, for instance, Pandacan, Tondo. Well, let's just add Quiapo. Okay, and then you get elements from random, not only one members, but 5 people from Quiapo, 5 people from Intramuros, 5 people from Pandacan, 5 people from Tondo as representatives. So those that is cluster sampling. So design of experiments. So a condition or a set of condition that is imposed on a group of elements by the experimenter is a treatment. Usually do that in clinical trials, for instance, in knowing efficacy of a certain drug. So the condition is, well, basically administration of the drug. So that's your treatment. And the procedure in which each elements are assigned to different groups at random is your randomization. So when the experimenter controls the elements to different treatment groups, that is a designed experiment. You are in control of who gets which treatment. Whereas in an observational study, you are not doing any treatment, you are just observing what happens. Basically, this is, for example, in clinical trials, for instance, of usually clinical trials are designed experiments. Observational studies, on the other hand, they can be classified under the phase 4 clinical trials. That is when that is after the drug has been released to the market and you are just getting the effect. So it's more of observational study because the experimenter does not impose the drug on the public. They just observe the public which voluntarily takes the drug. It's an example here is the vaccines. Phase 4 clinical trials can be done after its FDA approval and it's released. So it's our it's it's voluntarism. It's basically a voluntary choice of the population to get the vaccine or not. And for this observational study, the goal of the experiment are just to observe on the effects on the people who chose to get the vaccine. So that's your observational study. You are not exactly imposing any treatment on anybody. Everything is voluntary. Okay, so the group of elements that receives your treatment is the treatment group, and the group of elements that does not receive the treatment is your control group. So this basically the goal is, of course, if that is the treatment effective or not. Okay, so that's it for these basic terms in biostatistics. So this is copyright John Wiley and Sons. That's our lecture. So see you in the next part of the lecture.